Hello everyone, this is Rakesh. Today I'm going to talk about route reflector in iBGP. This is a very much important question asked by interviewer for the engineer role. If you're applying for the network engineer role, especially for the routing switching domain, it is a very important. You must know what is the route reflector, and I will give a brief about reflector, and I will not make this video longer. So let's read these lines and then I will explain you later. Right. So route reflector is a special BGP router, iBGP router, you can say, used inside the iBGP autonomous system to reduce the number of iBGP session. I mean neighbor, you can say, or peers, we can say. It eliminate the need for the full mesh iBGP technology. So how it work, I will explain later on this video. And let's also see why router reflector is needed. Simply like in iBGP, there is a by default rule that's called the split horizon rule, right? In that scenario, router will not advertise the route learn from the one iBGP to another iBGP session, right? What it does mean, right? So let me show you this one. So you can see here I mentioned three routers in this diagram: router 1, router 2, router 3. And you can see, if you see the routing table, this is the diagram and this is the routing table after the neighborship form between R1 to R2 and R2 to R3. So what is happening here? So you can see 10.10.10 subnet is directly connected to R1, and 20.20 subnet is directly connected to R3. And they already neighbor iBGP neighbor between R1 to R2 and R2 to R3, right? Correct. But when you see the routing table of R1, so you can see you are not able to see the 20.20 subnet in this routing table. And same thing, if you go to R3, you are not able to see the routing table of 10.10.10 of the R1. Why? Because when 10.10 subnet reaching to the R2, R2 is going to discard that routes, and it is not going to forward or re-advertise to R3 because of the split horizon rule, right? And to solve this problem, suppose that and that what happened in this case, right? This subnet will not reach to R3 anyway. So to solve this problem, we there is a two technique we have. That first one we can say full mesh, and second one we can say uh, route reflector. So full mesh is something like what we do from R1 to R3. We also make a neighborship. So you can see it will be, suppose that there is 4 5 6 router. So each router will make a neighborship with a different router. Like if I say suppose that let me see you suppose that there is this is also one router here, this is also one router here. If I say, and uh, so if I say this is also, there's 5 routers suppose, and when we're making neighborship between all of them, so what we'll do, so for the in the full mesh topology, what it will be, it will make a neighborship with this, it will make neighborship with this also, this router also make a neighborship with this router also make a neighborship with this and this, and same thing, this router will make a neighborship with this R2, and this route will make a neighborship with R3. So if I mention R4 and R5, right? So you can see how many neighborship is formed in this scenario. And in iBGP, when it's formed the neighborship, so it is directly connected to it, it can be advertised this route, right? And this one also we need to make a neighborship with this. So this in that scenario, R1 will advertise the 10.10 subnet to R3, and R1 will advertise to R5, R2, and R4. So each and every router will get a route information for 10 dot, and same thing happen will for 20, right? So, and you can see there's a lot of the multiple neighborship we need to create built between these of the router, right? So you can see it will be increase. What will be issue in that? It will increase the admin work. It will increase the routing table size, right? It will increase the CPU memory. So that is why we need to find the solution, and the solution of this problem is the route reflector, right? So if I come to here, so you can see if full mesh is not scalable, too many session will be formed, right? So that is why we use route reflector in real world, right? In real world problem, if you have a 50 router, then you have to make 1 2 to 5 IBGP session, and 100 router there is total, you can see 4950 session. So it is hard to manage, hard to troubleshoot, and CPU memory is heavy. So that is why we use route reflector to solve this problem. In route reflector, what will be happen, right? If we come to my original diagram, so in route reflector, there's no need to make neighborship between each and every router. It is, I mean, we no need to make uh, a mesh topology, right? We need not need to make a. So what will be happen in that scenario? Let me show you the diagram for the route reflector, right? So you can see here, you can see there is four router I mentioned here: router one, router two, router three, and router four. In route, what will happen in this? I will make this router as a server, and another R1, R2, R3 I will make as a client, right? And suppose that if it would be not a not a route reflector in full mesh, we need to make a neighborship between R1 to R3, and R1 to R1 to R2, R1 to R3, and R2 to R3. So you can see there's three more neighborship we need to form for the only four routers. So you can understand how many neighborship we are going to form if suppose there is 10 or 20 router in. But in a route reflector condition, what we'll do, this configuration is very simple. So we need to make a neighborship between route reflector to R1, RR to R2, and RR to R3. And if you go to the configuration, and what will happen in that scenario? Let's understand what is a server, what is a client first, right? So let's see uh, with the detail here. In key role of the route reflection, you can see when you configure route reflector, you categorized its IBGP neighbor into three types. Route reflector. So route reflector is, we can say it's server. It allowed to break the split horizon rule and pass the route between its client. And client router that peer with the route reflector and client do not need to be meshed with each other, and only need a session with the route reflector. And non-client is something like traditional, right? It does not take a participate in the route reflector process. If a non-client will need to make a neighborship, need to advertise the routes, it must be in full mesh topology, right? So yeah, so let's understand over here. So in that diagram, route only, suppose the R1 have 10.10.10, so it will advertise to the R1, RR, and RR will break the split horizon rule. Even they are part of the IBGP. RR will advertise that 10.10 router, 10.10 routes to R2 and R3, and same thing for the 20.20. It will R3 will only advertise to server, and server will break the rule for split horizon, and it will advertise to R1 and R2. So simply you understand now what is the benefit of route reflector. And configuration is very simple, right? So when you, what we need to do in that scenario, only route reflector had need a special configuration. We do not need to do any kind of configuration on router and R3, right? So you can see on route reflector RR, you can see just simply I'm not putting all the configuration here because I am making this video for the interview purpose only. If you are going to interview, then you can brush up your memory in a shorter time. So that is why I'm uh, creating this series for the network engineer interview, right? So only I'm not going to much detail. I'm just brushing up your memory, right? So you can see here route BGP 6500 is the you can say 6500 is the local AS number. Then I have somehow defined the neighbor, and remote will be 65000 because this is the iBGP, right? And you can see neighbor 10.1.1.2 and route reflector client. So when I will do configuration here, so when I'm making neighborship with R1, the only I will do configuration like neighbor, and then will mention as a route reflector client for if I'm making a neighborship with the R1. So I will only update extra command on route reflector. If I go to the client, so you can see this is simple as standard configuration, right? There's no any such changes for the client. So this is very simple. And sometime interviewer also ask what will be happen in the redundant uh, route reflector. Why he will ask why we need redundant route reflector? Because suppose that in case route reflector goes down, what will happen then? Everything so connectivity between R1 to R2 and R2 to R3 or R3 to R1 will be fail. So we cannot be dependent only on the one router. So that is why in case power outage or anything happen, then this will be very kind of outage scenario. So that is why we sometime interviewer ask what will be happen in the redundant, what is the solution for this. So for this scenario we can use a redundant route reflector. Right, so let me show you. Like here, you can see I have created a diagram. You can see this is route reflector one, route reflector two, and in that scenario, you can see R1 will make a neighborship with the both route reflector. R2 will make a neighborship with both R2, both route reflector, and same thing for the R3 also, right? And suppose that R2 will shut down, then all the routes can be advertised through RR1. And in case R1 will RR1 will go down, then RR2 will take a responsibility in that scenario. So you can see this is server 1, this is server 2, and same configuration almost. Let me show you the configuration here. So you can see configuration, what is the changes in the configuration in redundant scenario R1 R2. So on the Cisco, on the for the Cisco, I'm explaining for the Cisco IS configuration example. In this example, R1 R2 are redundant reflector for the client one. So you can see I'm just sharing with a example, right? This is not a this is not IP is not you can take any IP whatever you can, right? So I'm just mentioning the router, same thing, router local AS number here, router BGP local AS number, then BGP cluster ID 1.1.1.1. So this is the route reflector one, and in this redundant we need to set the cluster ID. You can see here cluster ID 1.1.1 pairing with the uh, redundant RR, treat as a non-client. So that is why it will be treated as a non-client. When same BGP cluster ID when I will create or configure on the RR2, so they will not treat as a client, they will treat as a route reflector, redundant route reflector, right? So they will, you can see neighbor 10.10.222 remote as. This is the simple peer client this is for the client configuration, right? So you can see here, and I just mentioning route reflector client. So it's simple, right? Where I can say, so simple, for a route reflector I will define the cluster id here. I will define the cluster id, right? Cluster id. And here also define the cluster, same cluster id, right? So in this scenario, both router will understand this, this is the redundant, and they will not treat as a client. So simple, and same configuration for the from rr1 and rr2 for the these three clients, right? And let's briefly look into the configuration here. So same thing will be on the r2 also. We can see cluster id will be 1.1.1, and you can see here any ip we can take. Uh, Mostly we used to take a private ip. So bgp cluster id, you can see 1.1.1.1 here, and neighbor will be you can see a 10.10 again. So when I mention the cluster id, it will be part of the redundant route reflector, and same configuration for the peering client as well. So there is no any such changes, and same things have explaining right on the client. There is the same configuration, there is no any such changes. So that is what I was trying to convey the information to you. This is a very very important topic for the interview, and I will make another important video for the network engineer interview. And thank you so much. I will add this document and split horizon document also in this video, so you can take a look. Thank you so much for your time. Thank you.